Hello viewers, thank you for watching my YouTube channel. I am David the nurse. I am a critical care nurse, and if you are yet to subscribe to my YouTube channel, please do so. Just press the subscribe button so that subsequently you can receive notifications for my videos. This week I'll be talking about an interesting topic called dead space. Dead space is a volume of air in the respiratory tract that does not participate in gaseous exchange. Now, gaseous exchange simply means the movement of carbon dioxide and oxygen in the direction of the concentration gradients. That is, the pressure of carbon dioxide in the blood is increased because the cells have used up carbon dioxide, so the CO2 pressure is higher in the bloodstream, and then blood is taken to the lungs for oxygenation, and oxygen is in high concentration in the lungs but is in lower concentration in the bloodstream. Let me say that again. The cells of the body have used up their oxygen and then released carbon dioxide. The blood is taken to the lungs for oxygenation. So the pressure of carbon dioxide in blood is high. Then in the lungs too, a patient inhales oxygen. So there is high concentration of oxygen in the lungs. So now comparing the high concentration of oxygen in the lungs to low concentration of oxygen in the blood, and then high concentration of CO2 in the blood with low concentration of CO2 in the lungs. And that brings about exchange in the direction of the concentration gradient. It means that CO2 can be easily released from the bloodstream into the lungs, and then the oxygen from the lungs can easily be exchanged and come into the bloodstream, and then that is how gaseous exchange takes place. Now, dead space is a volume of air in the respiratory tract that does not participate in gaseous exchange. And there are types of dead space: anatomical dead space, alveolar dead space, and physiological dead space. To understand these classifications, we need to come here and understand our tracheobronchial tree. And there are two major zones here: the conducting zone and the respiratory zone. In the conducting zone, gaseous exchange does not occur there. So the air contained in the trachea, bronchi, bronchioles, and terminal bronchioles, the air within that space does not participate in gaseous exchange. This may be due to the anatomical structure of the epithelial cells present there. They have thick epithelial cells, mostly columnar epithelial cells, which may be ciliated or non-ciliated, and this does not allow for easy diffusion through that thick membrane. So they only serve to conduct air, and that's why they are called conducting zone. So gaseous exchange does not occur in the conducting zone, and that's why we call this anatomical dead space. Anatomical dead space is a volume of air contained in the conducting zone of the respiratory tract. That is trachea, the bronchi, the bronchioles, terminal bronchioles. So this makes us understand that it is not all the amount of air that patient inhales that participates in gaseous exchange. We must get this very clear. In fact, the amount of air patient takes in at normal respiration is called tidal volume. And the average, that's the average tidal volume for an adult is 500 mils. It is said that only two-thirds of the tidal volume actually participate in gaseous exchange. That is, out of the 500 mils of air inhaled by the patients, only about 350 mils participating in gaseous exchange. The remaining 150, they remain at this level of the conducting zone. The remaining 150 mils remain at the conducting zone of the respiratory tract. So that is what we call the anatomical dead space. All right. Then move on to alveolar dead space. The alveolar dead space is also simple in the sense that it is the volume of air contained in the respiratory zones that does not take part in gaseous exchange. Now, it is expected in a normal condition, a healthy person, that the air within this zone, the respiratory zone, should participate in gaseous exchange. That's a normal physiological process. We understand quite well that in the conducting zone, there is no room for gaseous exchange to take place due to the epithelial structure in that zone. But in the respiratory zone, the epithelial structure allows for diffusion because they contain simple and thin epithelial cells, squamous majorly, and then it allows for easy diffusion of air in and out of it. So it's expected that gaseous exchange should take place in the respiratory zones. However, in disease condition such as infarction in the lungs like pneumonia, pulmonary embolism, pulmonary edema, cardiac failure, and some other disease conditions of the lungs can prevent some part of the air or some volume of air in this respiratory zone from participating in gaseous exchange. So the volume of air in the respiratory zone that does not participate in gaseous exchange is called the alveolar dead space. So we need to understand that there's a major distinction or difference between the anatomical dead space and the alveolar dead space. Anatomical dead space is related to the conducting zone, that is volume of air in the conducting zone that does not participate in gaseous exchange. Alveolar dead space is a volume of air in the respiratory zone that does not participate in gaseous exchange. Now, the last classification is physiological dead space. Physiological dead space is the sum total of anatomical dead space and alveolar dead space. I will say that again. Physiological dead space is the sum total of the anatomical dead space and the alveolar dead space. Now, this is what I'm saying. In a healthy person, physiological dead space is equal to anatomical dead space. What do I mean by that? In a normal healthy person, it's expected that there shouldn't be any dead space in the respiratory zone. So in a healthy person, you are expected to have just the anatomical dead space in a healthy person. So in a healthy person, physiological dead space is equal to anatomical dead space because in a healthy person, respiratory in the alveolar dead space is negligible because the every aspect of the respiratory zones are functioning well, and it's expected that gaseous exchange should take place here, and there shouldn't be any dead space in the respiratory zone here. But in a disease patient, in case of pathology and other things, then definitely there would be existence of the alveolar dead space. For instance, patient with pulmonary edema or pulmonary embolism, there will be some aspects of the lungs that will not participate in gaseous exchange. Therefore, there will be dead space therein, and the physiological dead space will now be the anatomical dead space plus the alveolar dead space. I believe that is well understood. So, because a lot of students confuse these types of dead space, the anatomical dead space is related to the conducting zone. Alveolar dead space is related to the respiratory zone, while physiological dead space is the addition. That is, if we want to write as a formula, physiological dead space is equal to anatomical dead space plus alveolar dead space. However, in a healthy patient, I'm going over it again. In a healthy patient, the alveolar dead space is insignificant or is negligible, in the sense that we are not expected to have any dead space in the respiratory zone of a healthy patient, because every air in this zone is supposed to participate in gaseous exchange. However, in a disease patient with pneumonia, patient with pulmonary edema, patient with cardiac failure, because in cardiac failure there is no much perfusion of the lungs. Now, if you have enough air in this region, in this respiratory zone, you have rich oxygen there, but there is little perfusion, there's little blood reaching the lungs. The um the entire lungs will not be perfused. So even though you have more oxygen, you have reduced blood supply to that area. So there will be a lot of oxygen there that will not be able to participate in gaseous exchange due to the reduced level of perfusion of that lungs. I'm just citing the cardiac failure as an example. There are other disease conditions that can also cause that. So, in a disease patient or in a pathological situation, there will be existence of the alveolar dead space. So, in that situation, physiological dead space will now be equal to anatomical dead space plus the alveolar dead space. I believe this video has been educative and you have learned a few things. Please feel free to share this video with friends and people that you think would benefit from it. Thank you so much. Please don't forget to subscribe to my YouTube channel. Thank you.